All right, let's do this. This is a cumulative review. So we have sampling, bias, and all the experimental designs. Okay, so let's take a look at what we got. All right, we got this flight. We have every 10th passenger coming in is going to be sampled. That's your systematic. Okay, now part B, where we have 5 from the first class and 25 from the other. Some of you and some of you and some from all the sections. That is stratified. They were homogeneous, first class and then other classes. I would have liked this problem more if they said 5 from first class, 5 from business class, and 5 from coach or something like that. All right. Now, C is 30 just randomly generated seat numbers. Okay. Nothing special. Just put them all in a random number generator and pull out 30 seat numbers. That's a simple random sample. Everybody had an equal chance of being selected. Now, here, you picked a seat position like right window, left window, center, aisle, whatever. And once you randomly selected one of those kinds, and once you selected one of those kinds, say you selected right window, then you picked everybody, all of those people on that right window. That is cluster. Hey, sample, or hey, cluster, you're a group. I will sample all of you. All right. Now, this is asking about the proportion who think Aledo High School students think academics is more important than extracurricular. So we do a cluster sampling, and we clustered by first period, and then we randomly selected 3 clusters and then sampled all of the students. So do you think that that's a representative sample? And I say no. Okay. And I wouldn't even say no because we don't have everybody here by first period. Okay. I don't even think that that's necessarily one, although that is possible because we have a lot of seniors who can have late arrival and are not here. Really, probably in our school, the more problematic component to that is the fact that first period classes have athletics and band. So those are 2 major, huge groups that are happening, particularly in first period. Maybe you should pick some other period, like second period or advisory. Okay. But, if you happen to pick one of the, Coach Buchanan's first period class, well, then you're going to get a lot of high overestimate of the proportion of people who think extracurricular is more important than academics or whatever. So this is definitely going to be under coverage because those first period classes are not miniature populations. Even if you just happen to get an AP class, they could have different opinions than on level classes in terms of thinking academics is more important than extracurricular. All right, so that's just a poor method in our layout of our plan. Here we go, number 3. So we want to get sophomores' opinions about the food. We said we have a setup, tell us what you think website. So do you think that that's going to be good? And no, that will not be, because inviting sophomores to call in or take action to put in their opinion is going to be only those who feel very strongly about the food served on campus. This is a voluntary response sampling method, which will result in voluntary response bias. So name the types of bias here, calling in your response, voluntary response. The interviewer asks a question, and that statement leads you to a particular answer. Well, that's a response bias. Your response is being altered because of the way the question is worded. All right, now here you want to go to your favorite place and you want to find out what the favorite place for snorkeling is. So what if you go to a neighborhood in Aledo, okay, or Fort Worth or wherever? Well, I mean, you only find 10 people in that area who have even snorkeled, okay? So that's non-response bias because that is just so few people. You're not going to get a well-represented idea of good places to go snorkeling. So here you ask the first 100 people that show up. That's definitely taking a convenient sample, and that is going to result, the type of bias is under coverage. Those first 100 people getting to that theater, the first 100 teenagers might not be like all teenagers. See, they could be the ones right after school. Their parents let them go right after school, but won't let them go later. Is that going to give a good representation of all teenagers' opinions? Probably not. All right, here we go. With this problem, our first study is just seeing who is currently on niacin and currently not. That's an observational study. That's just observing already existing conditions. The second one, you took the 50 people and you randomly assigned some of them to get niacin and some of them to get a placebo. That random assignment is an experiment. Okay, now you need to make sure that, here, this was randomly assigning students into two groups. So we just first started with our 30 people and we just randomly assigned them into two groups. Now, I had highlighted this information about how the patient and the doctor are unaware. I thought it was going to ask me something about blinding. It didn't end up doing that. It just said, what kind of design is this? Well, everybody went in the bag, shook well, randomly assigned. That's just a completely randomized, not a matched pair. That would be you found twins, or you've had them one person do both, not blocking by a certain trait. Okay. And a retrospective study is when you're just observing past information. Prospective is you identify them and then you follow them and observe only, not assigning a treatment like we did here. All right, so this was one asking about which of these statements is correct. And this, what happened was the students were either going to be listening to music or they were going to be, is this the one? They listened to soft music played at bedtime or they were given medication. Okay. So the interesting thing is it talks about blindfolds on them. Okay. That doesn't really have anything to do with being blinded. Um, this can't be double blinded, can't even be single blinded, because the patient would know if they're taking a pill or if they're just listening to soft music. If the patient knows what he or she is receiving, you can't have single blind. And you cannot have double blind without having had single blind. All right. The principles of experimental design. You make an experiment. What do you do? Control, randomize, repeat. Is blocking required for all experimental design? No. You do not. You can do completely randomized. You don't need to use blocking unless you think there's a trait that you need to control, because there's a trait that might affect the response we're measuring. Do you have to have a placebo? No. You can choose you may choose a placebo if you're measuring pain or you're measuring how you feel, and the subject might need to think that they're taking the medicine that's going to make them feel better. So if there's a subjective response where there could be some bias in clouding your judgment on your how you feel about something, placebo could help. All right. So on this problem, so I kind of struggled with this one. I think that the company probably wants to generalize. This is a company just finding a random district and using their students. So this is a company that probably wants to generalize their techniques to all algebra students so they could then go sell it. But I'm afraid that because of the way they designed it, I'm not sure if the students in that district are like all algebra students. If they are, then fine. So if those students in that district are like everybody, then good. If they are not like all kinds of students, I'm not so sure Alito students are typical of Texas high school students. Maybe they are, but I think we kind of have a little bit less variation amongst our students here than a lot of districts. And so I'm not so sure that we would be a good representation of all algebra students, maybe just the algebra students in our district. So they want to do to all algebra students, they probably only have the right for the students in the district. The sample is those 50 beginning algebra students. And so here we go. Here, this sample was the 100 high school juniors from the 5 different high schools. Same thing, to what population could you generalize? Okay, so this was an experiment and we were wanting to generalize. Really, probably only we can generalize to is the ones who volunteered. Okay, so this is something separate. We don't know. These juniors volunteered. So maybe they're very academically conscious students. They may not be like all students. So therefore, we probably should only generalize to them. All right. Here, who was our sample? Those 25 football players. Here, who was the sample? Those 100 male college seniors that were in this sample. All right. This one I think is a little confusing to me. For one, it's an observational study, so I mean, do we really have an explanatory variable if it's not an experiment? So that's something I've kind of wondered about this problem with. But anyway, it's about, of course, we're wanting to see what's going on with the lung capacity. So that's the response we're measuring. So number 18, we're measuring lung capacity. And we're doing that, we want to measure it from coal miners and farm workers. So that's why I'm choosing the coal miners, your occupation, as being the what we're wondering if that is having an impact or if that is the occupation is affecting that lung capacity. We do know there are various exercise levels, so we might need to control that, okay? But, and the smoking was the same for both groups. But I think the intent here is to see if the occupation is affecting their lung capacity. All right, number 19. Here, this is a randomized experiment because we had subjects randomly assigned to their treatment groups. Okay, randomly assigned to the treatment groups. And so the two treatments were the walking for half an hour and reading a book for half an hour. All right, those were the two treatments. Here we go with the true and the false. Lots of true false. So let's walk through these. Here we go. All right, some of them did kind of get redundant at the end. They kind of seem to be repeating themselves, but hey, I guess that means that that's a really important thing for you to make sure you know. Can you conclude cause and effect from an observational study? No, you cannot. There could be other traits in an observational study affecting the response. So you haven't controlled all of those traits. Okay, you can only conclude cause and effect if you have an experiment where you randomly assign to the treatment groups so you can claim the cause and effect. Randomly assigning will spread those unknown traits evenly to the treatment groups, so the only difference is the treatment itself. How about this one? You can generalize to the population if you randomly select your subjects from the population. Yes, when you randomly select, then your samples like the population, so you can generalize. When you randomly select, then your samples like the population. You can generalize, okay? So we can generalize if our sample is like the population. All right, now that brings me also to another point. Make sure when you read a situation, whoever you randomly selected from, that's who you have the right to generalize to. So in that problem with the algebra students, okay, so they maybe wanted to generalize to all algebra students, but they really only just randomly selected from that district's algebra students. So while they may want to have done that to all algebra students, I'm not so sure they have the right to generalize to all algebra students. All right. You can generalize to the population if you randomly assign your subjects. No, random assignment to the treatments, that's the cause and effect thing, not the general. The random assignment allows you cause and effect. Generalizing to the population can only be done with random selection from the population. All right. Random assignment to the treatment groups allows you to conclude cause and effect. Yes, that's what I just stated. All right, how about this? Does blocking allow you to conclude cause and effect? No, blocking is not what allows you to do that. Blocking is allowing you to control a trait that you think may be affecting the response. that you're measuring. But blocking is not what is allowing you to do that cause and effect. You could block in an observational study. You could do some blocking, and you can't do cause and effect with those. All right, how about this? Randomizing reduces bias. Absolutely. Randomize to reduce bias. Reduce bias. Now, what it does is when you need to spread unknown traits evenly, randomize, randomize. You're spreading unknown traits evenly to the treatment groups so that the only difference in the treatments is the treatment itself. So you are randomly spreading unknown traits evenly. You are randomizing to reduce bias. All right, here we go. Blocking reduces bias? No. Randomize to reduce bias. Blocking reduces variation. Let's see if that comes up next. Does randomizing reduce variation? No. Blocking reduce. Okay, so let's get this straight. Randomize to reduce bias. Reduce bias. Randomize reduces bias by spreading the unknown traits evenly. Blocking reduces variation. Our song, blocking reduces variation. You are making homogeneous groups. Homogeneous, see, making them all the same. I did all the same Akitas, all the Collies, all the Dalmatians. I reduced the variability. I reduced the variation and made them homogeneous groups. And we do that because I see you have a trait there that may affect the way subjects respond. So I make homogeneous groups to reduce variation. So 30 is true. Single blind means that neither the subject nor the evaluator knows what treatment. That's false because that is double blind. That's the definition of double blind right there. Single blind is just the subject does not know which treatment he or she is receiving. Stratifying does make homogeneous groups in your samples. Yep. When I'm doing, so remember our hey cluster, you're a group. I will sample all of you, hey cluster. But then stratify, homogeneous. Every single group is homogeneous. And then the video has the little Skittles bowls of all the same color. All the green Skittles, all the yellow Skittles, all the orange Skittles, and so on. And I get some of you and some of you and some of all of you. That's stratified. So blocking makes homogeneous groups in experimental design. That is true. Okay, so blocking is required. No, it is not required. It is something you want to do if there's a trait you need to control. But if there's not a trait you think you need to control, you don't have to block. All right, and placebos are required? No. Now, you do have to have a control group, but these people could get nothing. You don't have to give them a sugar pill or something that's fake, okay? You just do that if you're measuring something psychological, like pain or how they feel. Randomization is used to spread like subjects into treatment groups. That means like all the same kind of people here and all the same people there. Absolutely, actually, it's the opposite. Randomized to spread all the unknown. Actually, it's just all messed up. So you want to spread unknown traits evenly. So randomize spreads unknown traits evenly to the treatment group. That's true. Block by a trait and then randomly assign into the treatment. Yes. So if you were to write up an experiment, you need to block by the trait and randomly assign into a treatment. If there's a trait that affects the outcome or response, you should randomize it into homogeneous groups. Okay, so that's a problem right there. We do not randomize into homogeneous groups. Okay, we look at the subjects and we collect the ones together that are alike, like all of the active people, all of the non-active people. So that's false. And last but not least, if you think that there is a trait that you need to control, you should conduct a completely randomized experiment. Completely randomized is just everybody in the big bag, shake them well, and spread them out. No, if there's a trait you need to control, I see you have a trait there that may affect the way subjects respond. Then you block. Blocking is what you do if there's a trait you need to control. All right, That is our cumulative review for sampling, bias, and experimentation. And I hope that you have good luck on your test.